Hello, welcome to our continuing discussion on random variables. We're going to talk about transformations and combining random variables. So three things: linear transformations, combining random variables, and combining normal random variables. All right, when we have a linear transformation with random variables, when we add a constant, what we're going to do is we're going to add that measure to center and location. So mean, median, quartiles, and percentiles will all change in value. That addition of the constant c does not change the shape, and it does not change the measure of the spread, the range, the interquartile range, or the standard deviation. When we multiply or divide by a constant, b, this multiplies the measure of center and location. So mean, median, quartiles, and percentiles will be multiplied. It does not change the shape of the distribution. And then it multiplies the measures of spread, range, IQR, and standard deviation by b, the absolute value. All right, so let's take some examples. This is an example. We have De Anza College lists the number of units that full-time students take and the probability that they take them. So 12 units, probability is 0.25, 13 units, 0.10, 14 units, 0.05, 15 units, 0.030, and so on. So I want to use this information first to create a histogram of the probability distribution and provide the mean and standard deviation. So we're going to use this histogram, and then we're going to perform some transformations on this distribution in order to see what happens. Right, so I've created my histogram, and the left axis, the vertical axis, is probability, and the horizontal axis is going to be the number of units taken. And so you can see my distribution here based on the probability and based on the number of credits taken. And then I did some calculations. The mean is 14.65, and the standard deviation is 2.06. All right, now at Foothill College, the tuition is $50 per unit. I'm going to provide a histogram for tuition per student and the probability using the data from our prior slide and find the mean and standard deviation. So the cost now is equal to the units times $50. So what we're going to do is we're going to multiply units times 50 and then times so the units times 50, and then we're going to label, this should not be equal, but we're going to label the y-axis with the probability for the given value. So the given probability relative to the amount the student pays. Right, so we're multiplying that value of the number of units now by some constant value. It's $50. And you can see that the center and location are multiplied by 50. The standard deviation is multiplied by 50, but the shape is unchanged. So I've just basically taken the same histogram with the same probability values, and instead of the number of units now, I have the total cost. Since I'm multiplying everything by 50, these increments now are 50 instead of 1, which means the mean is going to change and the standard deviation is going to change, but the shape does not change. All right, now at De Anza, in addition to tuition, each full-time student must pay a $100 registration fee per semester. We're going to create another histogram using the data. And I think really I should have said Foothill, De Anza back here. So let me change it just to avoid some confusion. So this, we're sticking with De Anza here. And so now I'm going to add a $100 registration fee per semester. So we're going to create another histogram using this. So we're going to add that constant value that we were talking about, and also determine the mean and standard deviation. All right, so the location now shifts to the right. So center and location shift by 100. Standard deviation remains unchanged, and the shape does not change. So again, I took my same shape distribution with the same probabilities. Now I'm going to shift everything to the right. So everything, I'm adding 100 to everything here. So center and location increase by 100. Standard deviation does not change, and the shape does not change. All right, so this brings us to our first homework problem, 6.2.1. Right, the probability distribution of scores for Mr. Otten's FRQs is listed below. Find the mean and standard deviation of the distribution and create a histogram to represent it. All right, so here's the probability distribution and then the score. So your score is going to be on the x-axis and the probability is going to be on the y-axis. Okay, I am going to move on. All right, so when we have some linear transformation, we're given some random variable x, then y is equal to a plus bx does the following to the mean and standard deviation. Mean is the mean of y is equal to a plus b times the mean of x. And the standard deviation of y is equal to b times the standard deviation of x. So let's give an example to how this is going to work out. That prior slide is the theoretical part. Now let's talk about the practical part of applying what I just showed you very briefly. So let's give it some context for you to understand what this prior slide means. Right? So we want to define in context what this means. All right, so a baby bathtub comes with a dial to set water temperature. When the baby safe setting is chosen, the temperature of the water, X, follows a normal distribution with a mean of 34 degrees Celsius and a standard deviation of 2 degrees Celsius. Convert the distribution to Fahrenheit using the equation F is equal to 9/5 C plus 32 and find the mean and standard deviation. All right, so we said the mean is equal to 9/5 times x times, or plus 32. Right, so 9/5 times 34 degrees plus 32 is equal to 93.2 degrees. So we have the Fahrenheit converter. So we substitute the value of Celsius in, and we end up with 93.2 degrees Fahrenheit. If we want to figure out the change in the standard deviation, then we're just going to multiply that standard deviation value of 2 degrees by the b value in this case, right? Because the b value here in this equation is 9/5. We're just going to multiply the standard deviation for Celsius by 9/5 to convert to 3.6 degrees Fahrenheit. So the mean now becomes 93.2 degrees Fahrenheit. The standard deviation becomes 9/5 times 2, or 3.6 degrees Fahrenheit. So going back, we see the mean of y is equal to a plus b times the mean of x. So we're adding that constant value in here. Standard deviation, we're just multiplying by the absolute value of b. All right, so we get mean is equal to 9/5 times 34 plus 32. Standard deviation is 9/5 times 2, or 3.6. Okay. According to the National Council, we're going to continue with this problem, and we're going to expand it a little bit. According to the National Council for Babies, the temperature of a baby's bath should be between 90 and 100 degrees Fahrenheit. Find the probability that the bath, if set to the baby safe mode, falls within the Council's guidelines for safety. All right, so we said 34 degrees was equal to Celsius, 93.2 degrees Fahrenheit, and the standard deviation is 3.6. And we want to know what percent of the values lie between 90 and 100. So we're going to use technology, normal CDF, 90 lower limit, 100 upper limit, 93.2 is the mean, 3.6 is the standard deviation. And when we type that into the calculator, we end up with 0.784. Right, and then I drew a graph just to represent this. So I know that what I'm saying relates back to my normal distribution curve. All right, so this brings us to our homework 6.2.2. I'm going to put this up for a moment, and you can copy this down. Mr. Otten's AP class. The distribution X of raw scores on Chapter 5 test was normally distributed. The mean of 17.2 and a standard deviation of 3.8. Mr. Otten decides to multiply the raw scores by 4 and add 10. to find the variable y to be the scaled score of a randomly selected student from the class. Find the mean and standard deviation of y. What is the probability that a randomly selected student has a scaled test score of at least 90? So please copy this down, and I am going to move on. Right, second thing that I want to talk about, I'll talk about combining random variables. All right, so now we have Foothill College and De Anza College. We're adding random variables together. So sums of random variables, the mean of the sum of the random variables is a sum of their means. All right, so at Foothill College, students can take only 3 unit courses. This means the number of units taken will be 12, 15, 18. If we evaluate the number of units taken versus probability, we have the following: 30% 12, 40% 15, and 30% 18, where the mean is 15 and the standard deviation is 2.3. All right, so now we want to add both Foothill and De Anza. So let's say we randomly select one student from De Anza and one from Foothill. The expected mean value of units taken at De Anza is a little lower at 14.65. To calculate the mean value of the 2 randomly selected students, one from Foothill and one from De Anza, so this would be the average, we simply sum the mean of the units taken for each college. So 14.65 plus 15 is 29.65 units. All right, so we're just adding the means together to find the mean of the combined total. All right, so we can say for any 2 random variables x and y, if the total is equal to x plus y, De Anza plus Foothill, then the expected value of t is going to be the mean of x plus the mean of y. So the mean expected value of t is equal to the mean value of x plus the mean value of y. All right, so let's introduce or talk about independence again. If each random variable event has no influence on the other, then the random variables are considered independent. For example, the mean number of units taken at De Anza and Foothill are independent, which means that if the mean at De Anza goes up, it doesn't necessarily mean that Foothill increases also. All right, so the 2 events, number of credits taken going up or down at both De Anza and Foothill, are independent of each other. All right, variance. If 2 random variables x and y are independent, then the sum of their variance is equal to the variance of x plus the variance of y. So the variance of De Anza is 4.23, a squared standard deviation. De Anza squared the standard deviation for Foothill, I got 5.4. The variance of x plus y is 4.23 plus 5.4. And then the standard deviation is the square root of the sum of those values. All right, so you have to be careful. It's not standard deviation of x plus the standard deviation of y is equal to the standard deviation of the total. Right? That does not make sense mathematically. Right? So standard deviation of the total does not equal the sum of the standard deviations of the independent events. It only the sum of the standard deviations of the independent events, only the variances of the independent events. Does that sum rule apply? So the variance of the total is equal to the variance of y plus the variance of x. However, that does not mean the standard deviation of the total is equal to the standard deviation of y plus the standard deviation of x. What we have to do, and you can see that mathematically, if we take a look at the 2 values for the square, the variance for the total versus the standard deviation for the total. Standard deviation is actually 3.10, but that does not equal the sum of the standard deviations. The variance, however, does. When we want to find the standard deviation for the total, what we need to do is take the square root of the sum of the squared standard deviation values, or the square root of the sum of the variances. So be careful on this. And please let me know if you don't understand this concept in class. All right, so the mean of the differences of the random variables. So we're just subtracting the variance of the differences of the random variables is the sum of the variances, not the difference. All right, so please be careful on this last one. Intuition would say it's the difference of the variance, but it ends up working out to be the sum of these values. All right, so we're going to pause here. We're going to restart with an example. So please stop and then restart in just a moment.